Hello, my name is Ethan. I'm the CEO and co-founder of TextQL, and today I'm about to walk you through what we've kind of built out over the past 3 years. At a very high level, the kind of problem that we're trying to solve is one for most financial institutions, which is mostly around like data reconciliation, right? It's you have spreadsheets, you have tons of spreadsheets, you have a ton of data inside your data warehouses, inside your infrastructure, inside your databases that are spread across the cloud, on-prem environments, and you buy a lot of data from whether it's like S&P, whether it's Bloomberg, PitchBook, all these systems, and you cannot make the data reconcile between those places, right? The spreadsheet never matches the alt data sources, the APIs that you want to connect to. None of that matches to the databases that you have, and this is by far the single most expensive and most brutal part of being a head of data anything. You have to spend tens of millions of dollars on massive systems integrator projects, building ETL pipelines to clean, verify, and like deploy this to double check your work, double check like where the source is, and this takes place at a scale that cannot fit on any given single computer. And up to this point, there's never been an AI platform that can really address that. And so for the past 3 years, we've been building TextQL to give AI the tools, the infrastructure, the data virtualization, all of the parts of the data stack that make it possible for AI to be able to do work on big data, which really just means data that can't really fit on a single computer. We're used by some of the largest AI infrastructure providers like Scale AI, as well as like large deployments into hospitals and some of the largest asset managers across New York to do these kind of data migration work. To give you a sense of what I mean when I say really big data, this past generation of products, whether it's Glean, Claude, ChatGPT, these are really great platforms that have been centered around making AI that can interface with your like Office suite, right? Your spreadsheets, your presentations, your like docs, PDFs, all of those things that you can interface with on your computer. But when it comes to dealing with petabytes of data that are streaming from various sources into your environments, where you need real-time latency on every single one of these like trillions of rows, that requires a totally different type of algorithm and a totally different type of infrastructure to address. And so to jump into a very simple example that actually gets us to the demo, let's say somebody who you really, really like at your company messages you, here's a spreadsheet. Also, we spend a lot of money on all this like CapIQ data, all this Bloomberg data, and we have this like massive deployment of infrastructure in like Databricks and in Snowflake, and I can't join all this data together. Can you please help me figure it out? And really what they're doing is they're sending you on what for anyone here who does any kind of data engineering knows is probably like a 1 month long goose chase, as you have to like track down where the deltas take place. And so I should be able to show you this literally live right here. I don't know what that was. This is a mock-up of the S&P CapIQ market intelligence API endpoints where you can get companies' financials, financial information, all of this over like trillions of rows. I have a kind of a CyberSyn Snowflake-based, SQL-based data warehouse on the back end that is also powered by trillions of rows, although I can't show every single one of those rows on my computer for all the obvious reasons. And I have a spreadsheet that I've like downloaded from somewhere, who knows where. It has like multiple sheets inside it. It has financial data. All this information is about like Hewlett-Packard Enterprises. And if I hop into our system, which is a conversational interface that has a series of like running programmatic agents that can analyze this data, and I say, let's look into this. Let's see if there are any deltas in the data provided between Snowflake, API, the spreadsheet, reconcile this for me, try to figure out like how to interface with this information, try to figure out where which ones are correct, if there's a difference, take all the revenue values and like sum it up across the dimensions that make sense, and try to figure out just in general, like come up with hypotheses to test and figure out what's going on. So if I run this playbook, our agent will then go off and spin up a kind of a cluster that is like kind of predetermined. The data sources that I'm pointing at have this many rows, requires this much gigabytes of like storage or something, and you need to step through it. And you'll see the agent start to get to work. Now, we're not going to sit here and stare at this for the next 20 minutes because this is a deep research run and they tend to take quite a while. But if I go to a completed chat, here is the here's the example of what the workload it is, right? So this would be, if I had to do this, if my old boss asked me to do this in my last job, this probably would have taken me better half of like 2 weeks if I was really diligent, and if I was dragging my feet, maybe another 2 months. But this stepped through, it looked up all the sources that we have around the API infrastructure, right? It checked the schema, the metadata, all the compatibility stuff. Then it went in and actually looked at the SQL query itself, right? It started exploring what kind of tables are there, do I have access to, including, I guess, aircraft carrier indexes, and then drilled in further into what kind of like financial data can we drill into, right? Every single step, the agent is writing code that's being executed over like massive distributed systems, and then introspecting about the outcome of that code to come up with the next result, exactly the same way a human data scientist would, or a data engineer would. And as it's coming up with this hypothesis, it's looking at like, accounts payable, schedule series C, like something. I don't necessarily know what this term means, but it's like looking up like across its access to the metadata catalogs and all that information, how to resolve that information, and ultimately creating a series of visualizations that it can construct into a final visualization where it's able to elaborate on, I've looked through this, I've reconciled it. It looks like your Excel spreadsheet and the SEC filing are matching. The hypothesis, if you read through the rest of this, is approximately that the cash equivalents and things are there. The API data does not match, and there's no way you can make it match. We generated this synthetically. We deliberately did this so that that it's a believable example. It's not trivially like easy, and if we had another 30 minutes, I would take you down the rabbit hole of how the agent can then open up the ETL pipelines, all of the infrastructure that exists to make it possible for the API to be powered in the first place, and then introspect around that, figure out the error statements, write unit tests, and ultimately like debug the whole thing in chain. And yeah, that's the gist of it. This is a very, very toned down version of what this looks like to see this at scale. Because at scale, right, whether it's a large trillion-dollar asset manager that has a series of portfolio company holdings that it needs to build integrations to their CRM or ERP, you can set up these agents and then deploy them in bulk over like massive. You can set these up to run like thousands and thousands of these at a time, such that like anytime the data is off by some amount, deploy an agent to investigate why and repair that bug. Right? Anytime your fraud fraudulent like cancellation rates seem to be like spiking by like 3 basis points, deploy an agent and address that in a like fine-grained way, right? You have humans today that are working on this kind of workloads. They might be able to do, they're very expensive people. They can write code, so you have to pay them a lot of money. And they might be able to do it like any particular analysis at the level of like a per state per month, right? You can find a lot of alpha there, but as you think about like markets getting more efficient and analytics getting more and more like into the weeds, eventually you want to get that per city per state, or sorry, per city per week, per zip code per day, per person per second, and you can't do that with humans. You just can't like hire like 50,000 more humans to do that kind of data engineering work, and that's really what we've built our platform to do. And we thank you, Victor, for inviting us. We build our thing and deploy this into super compliance heavy environments. We serve a bunch of hospitals, serve a couple banks, work with a lot of asset managers. There's a whole like complex like set of infrastructure that we have to build out. All of this like runs in your VPC at large inside your on-prem. It's very regulated, and we have to run this in very regulated environments. And that kind of enables us to address, things in healthcare, things in oil and gas, in really like data at scale in like very like secure places. And if you're interested in this, we do workshops at people's offices. I don't know if there are that many people here who actually run data teams and have like serious big data issues. But if you have data that doesn't fit in a spreadsheet because it would kill your computer and blow up your RAM, happy to talk about what it would mean to deploy agents to solve those problems for you.